Hello, everyone. In this video, we will talk a little bit about linear programming. We would like to give a little background, maybe talk about a little bit of material that we don't specifically cover in MBA 535, but might be useful for some folks, and point to some additional resources. Begin with, it's worth mentioning George Bernard Danzig, who is considered the father of linear programming. Very interesting character, very intelligent man. Did a lot of work with linear programming, helped develop some of the techniques that we use to solve these types of problems, and had a very long and illustrious career, not only working for the military, but working for RAND and then for many years at Stanford. A very interesting story about Danzig comes from his graduate school experience. Now, this story, by all accounts, is real, and he shared it on a couple of occasions, but it sounds more like an urban legend than reality. So the story goes that when Danzig was in graduate school, he was late to class one day, and he saw a couple of problems on the board that the teacher had wrote on there and thought that they were homework problems. And so he hurriedly wrote them down and listened to the lecture and went on about his business. And, he decided to work on those problems and came up with some solutions. And he took the solutions to the teacher, who happened to also be his PhD advisor, and said, I'm sorry, I'm late with this. I'm sorry I was late to class, but here's my work. And the PhD advisor was busy doing something else, and he was like, yeah, it's fine, just lay it on my desk. And so Danzig did, and then left and didn't think too much more about it. Well, fast forward a few days, and early one morning, the PhD advisor is knocking on Danzig's door, and he opens the door, and Danzig's like, is something wrong? Can I help you? And the PhD advisor was saying, hey, I need you to take a look over this because we're going to submit this for publication. And he's like, what are you talking about? And he said, these problems that you saw, we're going to publish them. And it turns out that the two problems that were written on the board were not homework problems. They were famous unsolved statistics problems that the field had been working on for years. And Danzig, not knowing that and thinking they were homework, actually solved these two very famous unsolved statistics problems. Now, later on, he would recount, he said, listen, they did seem harder than normal, but I didn't realize that they were, these tremendous problems that had stumped academics for years. And so, I not knowing, I didn't have the wherewithal to know that they were beyond my ability. Turns out later on, in a PhD program, everybody has to write a dissertation. And when it came time for Danzig to write his dissertation and come up with a topic, he and his advisor said, listen, let's just write these two unsolved problems up and combine them, and we'll accept that for your dissertation. That's a wild story, and it has been used in the past to help people understand, when you don't know that there's limits, when you don't know that something's impossible, you can do great things. Danzig went on to have a very influential career. There's really something interesting about how a simple misunderstanding can lead to some really great things. So I've always thought that story was really interesting, and I wanted to share it with you. He's a very interesting character. If you want to, you could dig into more about him. He's won several awards. He had a long career and started several departments at Stanford. Really interesting guy. A couple other things that are really interesting as far as linear programming is concerned. The simplex method, the approach to solving these problems was developed during World War II and was part of the war effort for supply chain issues and things like that. I have read that the simplex method, the approach to solving the problems, was actually kept secret until 1947 because it was considered a very valuable tool that they didn't want the enemy to get their hands on. Moving forward, this work was done when Danzig was in the Air Force. He later went on to work for Rand, and we're going to speak more about Rand toward the end of this presentation for some additional resources. And then I've already mentioned his career at Stanford. Very interesting guy, done some really interesting work. Brilliant person. He's worth a read if you're interested in history and the technique and the like. So when we talk about linear programming, it is one of those tools that's very flexible. You'll see from the Render et al. Text that they use a lot of different examples. I guess the most common example and the one they use in the introductory chapter is about operations and the production mix problem. That's a pretty straightforward example and something that you can sink your teeth into. They also talk about finance problems with investment decisions. There's marketing mix problems, several of those in there. There's many more than that. Anything that you can conceive of as a problem with linear components, you can formulate a linear programming problem for. The thing to keep in mind is linear programming is not the same as computer programming. It's a mathematical approach to solving problems. So it has some really diverse and varied applications. Now, a couple of areas that we don't specifically focus on in NBA 535, but are direct extensions of linear programming and can be formulated as linear programming problems, involve transportation networks and other types of networks. And we're going to talk more about those here in just a second. The idea, though, is this can be applied to a bunch of different scenarios. It can be applied in a bunch of different venues. So if you're interested in it, this is another one of those approaches, those techniques that you can dig really deep into, and you can do a lot of different work with it. When you're looking at traditional management science type courses and management science type content, usually linear programming takes up quite a bit of bandwidth in those classes and in those courses. So feel free to investigate some more. One example that I wanted to share with you comes from, I think this is chapter 9 in the Render et al. Text, is the transportation problems. And in the transportation problems, what we're looking at is, okay, if we have products of some sort at one location or many locations, and we're trying to find the cheapest transportation routes to the end destinations where we meet the demand based on the supply that we have, linear programming can help solve those types of problems. When we're talking about a global economy and things like the supply chain issues that we see currently and what we foresee in the future, this is an important concept. A lot of logistics and supply chain courses will deal with these things, and they're worth taking a look at. If you're an entrepreneur and you have a small business and you begin shipping, or you would like to make your shipping operation a little bit more efficient, This is a good technique to know, and it's a good technique to explore. Um, we, if we had more time and we had more bandwidth, this is definitely something that we would cover in class explicitly. Just the fact that we have limited time to deal with certain topics. This is more of an optional module than a required one. But it's definitely an interesting topic and something that you could do a lot of work with. These two, the figure from the first slide and the figure from this slide are very similar, and that's because the setup is very similar in linear programming, but the objective is different, right? In the previous slide, we were talking about transportation and moving product from one location to another. We can also use linear programming in what they call an assignment problem. And an assignment problem typically deals with, what is the cheapest way to allocate labor, or what is the most time efficient way to allocate labor. And in this example, what we have is on the left-hand side, we have workers that are able to do certain jobs at certain rates. And on the right side, we have various jobs. And the idea is, in this particular problem, what's the lowest cost that we can achieve by assigning the workers to the different projects. Really interesting application of linear programming. The setup is very similar to the transportation problem, but a very different focus. Again, it is not something that we explicitly cover, but I could easily see that being something that is of interest to an entrepreneur or someone in a larger organization that is dealing with some staffing and some cost issues. Well worth a read. One final problem that we'll talk about that we don't specifically cover, but is an optional read for this module, this unit, is the network flow problems. There's a few different types of these in the Render et al. Text, and they do a good job of laying out some examples and showing you how to set up not only the visual representation, but the linear programming for it. The idea is, if we've got traffic or fluid or anything flowing through a system that has a series of nodes and a series of branches connecting these nodes, what's the best way, or what's the most efficient way to get material or people or cars or whatever the case may be through that network? For those of you that are working in public sector or maybe even with transportation logistics and supply chain setups, this could be something that's very interesting to you. A lot of times you can have publicly available data for traffic flows and things like that. Using that information and a little bit of linear programming, you can actually come up with a high-speed route through a particular area and make your travel a little bit more efficient, or your flow a little more efficient. One thing that's interesting is all of these, the transportation, the assignment, these maximal flow problems can all be set up and solved as linear programming. But the interesting part is, for a lot of software, there are special modules, special features in the platforms that deal with this. So it's actually even simpler than setting up a linear programming if you want to solve some of these problems. So it's worth your time if you're doing this kind of work and you're looking for more efficient ways to achieve some outcomes. These are worth taking a look at. Now, the linear programming that we study is the most basic form, right? This is a survey class, and we're trying to do a good introduction of the material. So we do the most simple linear programming setup. There are more involved approaches and more complex flavors of linear programming. And the render it all text does cover some of that as well. When I talk about goal programming and integer programming and nonlinear programming, oftentimes businesses will have problems that don't meet all of the assumptions of simple linear programming. And because of those deviations, you need some more developed approaches. The rendered all text does a great job of giving you some background in that. And for folks that are interested in it, I highly recommend you check that out. It's another one of those recommended or optional chapters in the text, but it's got some really interesting applications. And I invite everybody to take a look at that if they have the time. Now, finally, just to wrap up, I'll give you a couple of interesting additional resources. Beyond the rendered all text that we use for MBA 535, this managerial decision modeling text that Render is also an author on provides a good example of management science. The first 6 chapters in this textbook actually deal with linear programming and linear programming extensions. So if you're interested in this technique, in learning more about it, this is a good additional resource. There's some nice internet resources available that are associated with it. It's a good additional asset that you can purchase and have in your personal library. One other resource that I wanted to share with you is this Quantitative Methods book by Brandon Marte. It is a more advanced text than what we use. It actually has more significant applications in linear algebra and calculus and more advanced treatments of a lot of the topics that we cover in this class. It does have some linear programming content in it. It also has some basic statistics content and some decision analysis content in it. For those that are looking for some more sophisticated mathematical treatments and technical explanations of the topics that we cover, this is a good resource to have. It's a Wiley book. It's fairly well known. It provides a lot of additional content that can take you to the next level in your analysis of capabilities. I think since it does have a strong linear programming component to it, this was a good time to share this resource and to let everybody know about it. Now, finally, 3 additional sources of information that you can find on linear programming. That first one, the RAND study component. If you go to that link, you can actually find, I think it's the 1963 book that Danzig wrote outlining linear programming, right? So you can go to some of the source material of what the technique is, how it was developed, what it involves, and some examples that they were working with at that time. I think it's broken up into 3 files, 3 PDFs, but you can download the entire ebook for free. You can also purchase a bound copy for it at a very reasonable price. So those that are interested in linear programming and a little bit of history, that's a nice resource to look up and to have. This MIT brief, the second component here, that is a very brief write-up of linear programming. The mathematics do involve some of the linear algebra instead of the more simple approach, but it's got a real nice, almost outline type presentation of linear programming. For those of you that maybe want sort of a primer before you dig into the more involved chapters in our textbook, in the Render It All textbook, that's a nice resource that's available. And it points to some other software that you can use to solve linear programs as well. And then finally, I found this resource a few years ago, this Linear Programming Theory and Applications by Catherine Lewis. It's available online. Really nice treatment of linear programming. Gives you a lot of background, some of the more advanced mathematics. A very clear and a very nice piece of work by Lewis. For those that are interested, this is something that you'd want to take a look at. All right, folks, that's a brief introduction to linear programming, a little bit of history, a little bit of urban legend, and then a few additional resources that you can check out. I hope that the folks that are interested in this will dig a little deeper, and I wish you the best of luck with linear programming.